Good morning, ladies and gentlemen, and welcome to the Royal Institution, one of my favourite places in London. My name is Ralph Rayner, and I'm co-chair of the IMarEST Operational Oceanography Special Interest Group. We have a fascinating programme lined up for you today, for which I thank the efforts of all of the Oceans of Knowledge Organising Committee for their hard work over what's been the last 2 years. We start planning these events 2 years ahead. Anyone that hasn't been involved in planning an event will have no idea how much effort is involved in trying to pull something like this together. I'd also thank our sponsors, the Met Office and Fugro, our badge sponsors, Storm Geo, Met Office and Fugro our sponsors, our badge sponsor Storm Geo, and Delegate Pack sponsor Planet Ocean. Again, without their support, we couldn't make these events happen. As you'll hear, our day, in this day, there are many opportunities associated with a growing ocean economy. You will also hear that these opportunities come with some associated challenges. How do we adapt to serving new markets? How to embrace very rapid technological change? And most important of all, how to realise the use of the ocean and ocean resources in a way that protects the ocean environment. I'm now going to hand over to my fellow co-chair, Gus Jeans, who is going to introduce the speakers for this morning. Over to you, Gus.
Thank you, Ralph. I'll be very brief. My name is Gus Jeans. I'm the co-chair with Ralph of the OOC, we call it, the Special Interest Group, and we'll be sharing those chairing duties this morning. So the morning is about high growth areas of the ocean economy, and our keynote speaker is Marit Undseth from the OECD, who will talk about some of their work in this area, looking ahead at the growth in the ocean economy, which will set the scene for the discussion this morning. So over to you, please, Marit.
Well, thank you very much, Gus, for introducing me, and thank you for inviting me to the event today. So, as said, I work at the OECD in the Directorate for Science, Technology and Innovation. And today I've been asked to talk about all these important topics. I will provide an overview of our work of understanding the current and future ocean economy. I will identify some of the challenges of a growing ocean economy and also the role of STI in addressing these challenges. Let's see what it is. So the OECD Directorate for Science, Technology and Innovation's work on the ocean economy is ongoing since the launch of the first project in 2013, and it builds on findings of the Foresight Report of the Ocean Economy in 2030. So our key objective is to provide evidence-based information to improve the research and innovation policy mix for sustainable ocean management through statistical work and economic analysis. As you may know, the OECD is not an environmental organization as such. It was created just after the Second World War to support the implementation of the Marshall Plan, but its work today is to support policy making, mainly through statistical work and also policy reviews. So the work on oceans has been ongoing since 2013. So our current work program is organized around 4 major themes: economic measurement and ocean industries foresight, knowledge and innovation networks in the ocean economy, exploration of new indicators of science, technology and innovation in the ocean economy, and economics of ocean observations. These activities all contribute to the broader priorities of the OECD Committee on Science and Technology Policy, including, for example, digitalization and emerging technologies for addressing grand challenges. So my presentation today will have 3 parts. I'll first go through some of the opportunities and challenges that result from a growing ocean economy. Then I'll move on to reviewing the ways SDI may contribute with examples from our latest reports. And finally, I'll give some pointers to the way ahead. So I'll start by presenting some of the main findings from the Ocean Economy 2030 report, which was the first report published by our group in 2016. So the ocean economy in 2030 explored the growth prospects for the ocean economy and its capacity for employment creation and innovation. It was a cross-sectoral, cross-disciplinary foresight exercise with 3 different scenarios, business as usual, and 2 scenarios with respectively sustainable and unsustainable development. Particular attention was devoted to the emerging ocean-based industries in light of their high potential for growth, innovation, and contributing to addressing global challenges such as energy, environment, climate change, and food security. Hence, the report examines the risks and uncertainties surrounding the future development of ocean industries, including required innovations and the environmental impacts of the industries, both in terms of their potential contribution to green growth as well as negative externalities. Finally, and looking across the future ocean economy as a whole, it explores possible avenues for action that could boost long-term development prospects while managing the use of the ocean in a sustainable way. So what is the ocean economy? Well, it means different things to different people. At the OECD, we define it as the sum of the economic activities of ocean-based industries and the assets, goods, and services of marine ecosystems, which for us are 2 complementary and mutually dependent pillars, where one cannot exist without the other. In many cases, marine ecosystems provide intermediate inputs to the ocean-based industries. Conversely, ocean industries can affect the health of marine ecosystems. This definition has direct consequences on measurement, because you tend to manage better what you can actually measure. And so far, we have only looked at the ocean-based industries. What we call ecological or ecosystem accounting, which means an inclusion of the value of ecosystem assets and services in quantitative assessments, is a new and still experimental research field. So here's a list of the industries in the ocean economy that was included in our analysis. It's about 20 different industries, including established and emerging industries. We decided to separate them in 2 different groups. I think you know most of them here, but there will be presentations on several of the activities. It's important to note that there's no hard distinction between these 2 groups. Some segments of established ocean industries may manifest clear indications of rapid growth and quite dramatic rates of innovation. For example, shipping and port activities are moving increasingly to highly sophisticated levels of automation. Coastal aquaculture at industrial scale is becoming a highly science and technology intensive activity and is looking to expand further offshore. Ocean monitoring and surveillance are benefiting from massive advances in satellite technology, tracking and imaging, and the cruise industry is also turning its attention to new destinations such as the Arctic and Antarctica. So all this creates exciting new opportunities, but also many more challenges, typically seabed mining and offshore wind. So as you can see on this chart, future projections show a marked acceleration of economic activity in the ocean based on the rapidly expanding ocean industries combined with expectations of moderate growth in already large industries like maritime and coastal tourism, offshore oil and gas, shipbuilding, and maritime equipment. According to our projections, the ocean economy could double in size by 2030, reaching a gross value added of around $3 trillion, following the business as usual scenario. So the value added of some ocean industries is set to grow much faster than the world economy. This includes, for instance, marine aquaculture, capture fisheries, fish processing, offshore wind, and port activities. As you can see, these data start to get a little bit old, so we will produce new time series in 2020, just for your information. So one key message of our report and of our work in general is that growth is not sustainable. It is almost inevitable that pressures on the ocean's natural assets will increase in the coming years as demands continue to grow on marine sources of food, energy, minerals, leisure pursuits, and so on. Similarly, ocean space in many regions of the world risk becoming ever more crowded, as maritime trade, marine aquaculture, ocean renewable energy, and marine coastal tourism gather momentum, and by virtue of their growth, generate further demand in related interconnected ocean-based industries. And several of these economic activities are contributing to a range of challenges, such as climate change, accompanied by sea level change and acidification, the deterioration of ocean and coastal ecosystems, marine biodiversity loss, plastic pollution, declining fish stocks, etc., etc. So this translates into a need for more knowledge of the ocean by observations, understanding better how it functions as an ecological and biochemical system, and how an increasingly unhealthy ocean affects the planet and society as a whole. And it also calls for greening of polluting industries. So this is where we need SDI, which can make key contributions in several areas. So first, SDI plays a crucial role in contributing to filling knowledge gaps. I'd say that more than 95% of the depth of the water column and the seabed remain largely unexplored, especially when it comes to deep ocean data. Only a fraction of existing data have long time series and for levels below 200 meters. Furthermore, SDI policies and institutions support the development of technological solutions addressing climate change and sustainability at both the national and international level by identifying cleaner alternatives, polluting technologies, reducing emissions, treaties, enforcement, and other things such as such technologies include advanced materials, nanotechnology, biotechnology, autonomous systems, satellite technology, big data analytics, etc., etc. New technologies also increase competitiveness of the sector with efficiency and productivity gains. And finally, SDI contributes to tackling highly complex technological challenges, for example, subsea engineering. So this is the context of our latest report, which was published in February 2019, called Rethinking Innovation for a Sustainable Ocean Economy. It explores the role played by SDI to propel growth in the ocean economy while providing solutions to the long-standing issues of sustainability. So I will give a few messages based on this ongoing work, knowing that there is much more in our report. First of all, dealing with all these challenges requires fresh thinking in many areas. The time is right to explore innovative approaches as many changes are unfolding in the science, research and innovation policy landscape. So this includes, for instance, the acceleration of research and innovation processes in most disciplines and in sectors of the economy. Markets clear faster, ideas spread more quickly, and the time buffer associated with distance shrinks. So the adoption of disruptive technologies boosts productivity and create entirely new opportunities. And several high technology ocean industries have been early adopters of these technologies, for instance, artificial intelligence, robotics, cloud computing, blockchains, etc. And then there is also a growing number of more collaborative and open innovation mechanisms worldwide, as the distribution of scientific information can be done at marginal additional cost. So greater access to scientific information can help to make science more inclusive and accelerate the uptake and translation of this information into societal benefits. So the report explores different types of innovation and how these can be leveraged to benefit a sustainable ocean economy. First, it looks at how science and technology can drive environmental sustainability. Secondly, it looks at innovative ways of organizational collaboration. And third and finally, it looks at innovative ocean economy measurements. So in this presentation, I will focus on findings from the first 2 points, technologies and collaboration. So which innovations are on the horizon that may benefit both economic growth and environmental sustainability? So as it happens, there are several several innovations in the pipeline that appear set to enhance knowledge and understanding of marine ecosystems and their functions, and improve also ocean industry's performance markedly. And the report presents 4 case studies on offshore wind, conversion of oil rigs, ballast water treatment, and marine aquaculture, where technological development is showing some very promising results. Several of these technologies will be discussed at much greater length at the conference here today, but I would just like to share some of the main findings. So we found that these technologies could bring considerable economic benefits, both in terms of economic gains and spillover effects to other sectors. Second, they could also potentially bring benefits to marine ecosystems and the environment, provided that their application is based on robust scientific knowledge. More scientific research data and knowledge is essential. And it is important to note that the step change progress in the development of sustainable ocean activity requires multiple innovations from different disciplines and sectors. So this leads us to innovation in collaborative processes. Successful innovation in science and technology often requires fresh thinking in the organization and structure of the research process itself. So our report focuses on a particular type of collaboration among marine and maritime actors, innovation networks in the ocean economy. So innovation networks specifically dedicated to the ocean are a fairly recent phenomenon. Many have emerged in the last 5 to 10 years. They strive to bring together a diversity of actors, for instance, public research institutes, large enterprises, small and medium-sized enterprises, universities, public agencies, etc., into flexibly organized networks. They work on a range of scientific and technological innovations in many different sectors of the ocean economy, robotics, autonomous vehicles, aquaculture, offshore oil, etc., and in many parts of the world. So the OECD conducted a survey of 10 selected networks with publicly organizations at the core, or at least partly. And such organizations often play a crucial role in orchestrating activity on behalf of the rest of the network. Facilitating effective collaboration is a central feature of a network's success, but multiple challenges are associated with doing this effectively. So these are the actors that we looked at. I think there are 9 listed on the slide. There is also a 10th center, the National Oceanographic Center in Southampton. So as I already said, all these centers are wholly or partially publicly funded, and the majority of centers are located in Europe, with one in Canada. They were identified by the OECD Secretariat or recommended to us by our steering group. This is just a very small sample, and all findings are, of course, indicative. We will do another bigger survey with more actors and more questions next year. So the survey tried to identify some of the underlying motivations for joining a network, how innovation outcomes are shared, and more generally, detect some preliminary benefits of these activities. So examples of benefits produced include those accruing to network participants, such as improved cross-sector synergies, access to once inaccessible research facilities, and specialized knowledge, and dedicated support for maritime startups. Other associated broader benefits include the building of marine scientific capacity and knowledge, and contributions to sustainable regional and national economic activity in general. Challenges faced by the Innovation Network Centers include successfully building bridges between organizations with differences in purpose and objectives, balancing opportunities for fundamental research and commercial potential, and maintaining a culture of innovation among all partners. In brief, in order to maximize the benefits of these networks, they need to be actively used by all the actors in the ocean innovation ecosystem, including universities and government organizations, and research centers and private enterprises. where independent assessments of the impact of ocean economy innovation networks have been carried out, they have shown generally positive impacts within and beyond the ocean economy. However, more efforts to assess the cost effectiveness of public expenditure on innovation network centers is required if the value to society is to be better understood. So more studies are needed to assess impacts in this area. So to conclude, development of the ocean economy is facing an increasingly acute dilemma. On the one hand, marine resources are essential to help meet the planet's growing needs in food, energy, jobs, medicines, transports, etc. On the other hand, the increasing use of our seas and ocean, the natural resources and the services they provide, adds to mounting pressures on marine ecosystems. A long journey lies ahead to gather the information, data, analysis and knowledge that is vital for decision making in the ocean economy at all levels, from local to global. And we therefore need to promote innovations that better conserve and sustainably use marine ecosystems. We need to foster and monitor innovation networks to create new synergies and spur further innovation and knowledge creation. And also we need to improve measurements of the ocean economy through standardized measuring and valuing of industries, integrating natural resources and ecosystem services into national accounting frameworks, and better identifying and measuring the benefits of public investments in ocean observation systems. And I believe that this conference contributes to these goals. And with this, I thank you very much for your attention.